Evaluate the following limits. The limit of tan 2x over x as x approaches 0. Okay, so if we substitute 0 in place of both of these x's, we're going to get 0 over 0, which is indeterminate, which means we cannot determine the limit. So we're going to have to rewrite this another way. So tan 2x over x becomes sine 2x over cos 2x multiplied by 1 over x. So let's have a look and see why that is. So this is our rough work here in the red. So tan 2x over x can be factorized as tan 2x over 1 multiplied by 1 over x. So we're breaking this apart into two fractions. You could say we're multiplying by 1 over 1, which is just 1, which does not change the value of the fraction. So if you multiply back just to check that it makes sense, so tan 2x multiplied by 1 is tan 2x, and 1 multiplied by x is just x. So it works. Now tan 2x over 1 is tan 2x, so still multiplying by 1 over x. And tan 2x can be rewritten as sine 2x over cos 2x. So this is one of our trig identities, and it's found in our formula book. So I'll show you in a minute where that comes from in our formula book. So tan 2x over x is rewritten as sine 2x over cos 2x multiplied by 1 over x. Okay, so let's zoom in on this section. So what we're going to do is take the 1 from our 1 over x and place it here, and take the cos 2x and put it underneath. So we're basically putting these two together. And we can do that because these fractions are multiplied, so we can order them in whatever way we want. Then the sine 2x comes over here. And we originally had x, but we're going to stick on a 2. Now remember, multiplying a number by a letter, you stick them together. So what you've really done here was multiplied the denominator, which was x, by a 2, because you're sticking on a 2. Now if you multiply the bottom by 2, you must multiply the top by 2 so that the value doesn't change. So we multiply the numerator by 2, which would be really 2 over 1, or you can just write 2. So we have 1 over cos 2x multiplied by sine 2x over 2x multiplied by 2. Now cos 2x, if x is going to be 0, is cos of 0, which is 1. So this will end up being 1 over 1. So 1 over 1 just gives us 1. Sine 2x over 2x is our special trig limit, which gives us 1. And 2 stays as 2. And 1 times 2 is 2. So the limit of tan 2x over x as x approaches 0 is 2. So here we have page 13 of our formula book. And we can see on the top left hand side that tan of a is equal to sine a over cos a. So in the example that we were doing, we had tan 2x is equal to sine 2x over cos 2x. And this is one of our trig identities. So we don't have to learn this off, it's given in the formula book, and we will cover this in detail in our trigonometry chapter.